In this video, I'm gonna explain the first lesson in physics for the first year secondary of the General Secondary Certificate, hoping that helps you understand difficult and mysterious points and paves the way for your excellence. In the first lesson, we are gonna explain or discuss measurements or physical measurements. What's meant by measurement? Measurement translates our daily observation into quantitative amounts that can be expressed in terms of numerals. For example, the beam balance, has 2 pans. We can put some apples here. Apples. I don't know the mass of these apples, and I want to know the mass. So this we can call it unknown mass. On the other side, or in the other pan, we put some pieces of metals. Each metal has 1 kilogram. So on this side, I have known mass, and the other side we have unknown masses. So now I know the apples, the mass of these apples equals 1, 2, 3, 4, 5. This is the measurement. This is the simple way to understand measurement. So what's meant by measurement? Measurement is the process of comparing an unknown quantity with another known quantity of its kind, called the unit of measurement, to find out how many times the first includes the second. Okay, so now I know the mass of the apples is 5 kilograms. That is the simple way to understand measurement. You use measurement in your daily life. So if you want to measure something, you have to have 3 key elements. What is the key elements of measurement? If you want to measure something, you have to have 3 key elements: quantity, the second is tools, and unit. The 3 key elements of measurement: quantity or physical quantities, tool, and unit. We will discuss in details each element of these elements: the physical quantity to be measured, the necessary measuring tools, the units of measuring used. The physical quantities that we deal with, such as mass, time, length, volume, etc., are called physical quantities, and we need to measure them accurately in our daily life. Physical quantities can be classified into 2 terms: fundamental quantity, and derived quantity. What's the difference between them? Let's start with fundamental quantity. What is fundamental quantity? Fundamental quantity is the physical quantity that cannot be defined in terms of other physical quantities. Fundamental, from the name of fundamental. You know, fundamental means basics or base, like mass. Mass is a fundamental. You cannot define mass in terms of length or in terms of time or velocity or any other physical quantities. So I can say that fundamental physical quantity, it's the physical quantity that we know, that we recognize in the first. It looks like your address. If you build a city, the city, first you have to make base places like hospital, like school. You cannot change the address of the school, of the hospital or the hospital, but you can change your address. You can move from house to another house, from your flat to another flat, but the address of the hospital is the base address. It looks like that. Fundamental quantity is the physical quantity that cannot be defined. It cannot be defined in terms of other physical quantities. For example, length, we will use notation for each quantity. So you have to know the symbol of the quantity. Length or length, we will choose L, like this, L or L. Time, capital T or small t. Mass, M, capital M or small m. We will use each symbol or the notation. These are the notation of this quantity. So time is a fundamental physical quantity because time cannot be defined in terms of other physical quantity. If you want to define velocity or speed, you have to measure the length first and divide the length by time. So if you wanted to define speed, you have to know the length and time. So speed, define it in terms of length and the time. Speed is derived from length and time. So speed is a derived physical quantity. What is the derived physical quantity? It's a quantity that can be defined in terms of the fundamental physical quantity or quantities, like speed, like area. Area equals length times width. Volume is a derived physical quantity because volume defined by length times width times height. You know, volume and area and speed, all of them are derived physical quantity. Displacement and time and velocity, these are quantities. But you know, displacement is a physical quantity, a fundamental quantity. Time is a fundamental quantity, but velocity is a private physical quantity. The relation among these physical quantities can be expressed in this equation. Velocity equals displacement divided by time I can call this physical mathematical equation, or in this way, V equals D over T. So what is physical mathematical equation? What does it mean? Okay, as you see, it is a shorthand formula to give a physical illustration. V means velocity, D means displacement, T means time. So the physical mathematical equation means a shorthand formula to give a physical illustration. It's important to know that. The second key in measurement is measuring tools. Man in the past used parts of his body and natural phenomena as tools of measurement. He used the arm, his arm, the hand span, and foot as tools to measure length. Also, he defined from the sunrise, the sunset, and the moon phases, and devising a measure of time. However, various measurement systems originated and developed in different countries. The measuring tools have been tremendously developed in the context of the Great Industrial Revolution next to the Second World War. Consequently, these tools were very helpful to man in describing phenomena accurately and exploring facts. The used measuring tool depends on the physical quantity to be measured. So the first step to measure any physical quantity is to choose the suitable measuring tool. We are gonna to know the tools to measure length, mass, and time. First, I think you know how to measure the length easily. If you wanted to measure a long distance, you have to use meter tape. So meter tape is a tool to measure a long distance. If you wanted to measure a short distance, you can use your ruler. Ruler is a tool to measure short length. If you wanted to measure a very short distance, like the radius of the spin, radius or diameter, okay, you can use vernier caliper. Very short distance. If you want to measure a very short distance, like the diameter of one hair, you have to use micrometer or micrometer. Okay, these are the tools to measure length. What about the tools to measure mass? What about mass? Roman scale. You know, beam balance. I think you know beam balance well. It has two pans. You can use analog scale or kitchen scale or bathroom scale and digital scale. These are tools to measure mass. What about time? In the past, they used to measure time with hourglass. Hourglass, as you see in the picture, it has two sides and it has sand inside it. Okay, there is clock. You can measure time with clock or stopwatch or stopwatch, as you like to say, and digital watch. These are tools to measure time. I think they are easy to use. There is a question. If you know the answer, please write the correct answer in the comment. The question says that the suitable tool for measuring the radius of a small metallic sphere is the ruler, number B, the vernier caliper, number C, the meter tape, number D, the sensitive balance. If you know the answer, please write the answer in the comment for the first question here in this video. Okay, thank you. The third key in measurement is measuring units or units. You can say it units. Yeah, we can say units. Any quantity without its unit is meaningless. So each physical quantity, either fundamental or derived, has a measuring unit. So for example, I can say the mass of a body equal 5. Mass of a body equal 5. Do you know what does it mean, 5? We can't estimate the mass. We can't know the mass. What does it mean? 5 grams, 5 kilograms, 5 ton? We don't know. So if I write the unit kilogram, now the quantity is fully clarified and you know the amount of this quantity. If I say the length of this body is 5, what does it mean? 5 millimeters, 5 centimeters? You don't know. But if I say 5 meters, now you know the length. There is an important thing you have to know: the notation. We can say the mass of a body, any body, equals 5 kilograms. But in physics, we cannot write all of these words. We just write M means mass equals this symbol 5 kilograms kg. These are the notations of in physics. M means mass. These symbols means equals. 5 means 5. Kilograms, kg means kilograms. So we will use these notation. Okay, there are several systems used all over the world to determine the fundamental physical quantities and their measuring units. The first system is the French system. The French system. The second one is the British system. British system. The third system is the metric system. All of these systems used 3 units for the 3 fundamental physical quantities. Length means L means length, mass M means mass, T time. In the French system, the unit of length is centimeter. We can write it cm. It means centimeter. Okay, centimeter. And for the mass, they used grams or G. G means grams. For time, they used second, S. We can write the French system like this: C, G, S. And we can call the French system Gaussian system. Gaussian system, the French system, CGS system, they have the same meaning. What about the British system? The British system used for length and mass and time. You have to know the meaning of these symbols. They used foot, FT, or feet, as you like. Foot for length, pound for mass, LP, but we call it pound. For time, they use second, S. We can call it FPS, okay? Like the CGS. What about the metric system? The metric system, they used for length and mass and time. The metric system solved the problems between the Gaussian system and the FP system or British system. The French system used centimeter and the British used foot. So the metric system used meter, M, meter. And in the French system, they used gram, and the British system, they used pound. So the metric system used kilogram. Because the French system and the British system used the same unit, so the metric system used the same unit second. The scientists agreed to add other 4 fundamental physical quantities to the metric system, and they called it the modern metric system or the international system of units. International system of units or the modern metric system. Or we can write it like this: SI, just SI, but we put the letter S before the letter I because it comes from the French language. In French language, they say Système International. So S before I, okay? So we write it like the same we write it the same SI, okay? We have 7 fundamental quantities. Like a metric system, we have length, we have mass, we have time, we have electric current or electric current intensity, and we have the absolute temperature, amount of material, luminous intensity. These are 7 quantities. These are the 7 fundamental physical quantities. We can write length like this: L, mass M, small m actually, time small t, electric current or current I. And instead of writing these words, the absolute temperature, capital T, amount of material, number N, luminous intensity, IV. Okay, these are the quantities. Okay, what about the units? Okay, the units, the international units. For length, we use meter or M. Mass, we use kilogram or kg. Time, second or S. Current intensity, we use ampere. It's a French word. A. Absolute temperature, we use Kelvin or K. Amount of material, we use mole or MOL. And luminous intensity, we use candela or CD. These are the 7 fundamental physical quantities and their units, the international units. Then after that, the scientists added 2 other units for these units. Actually, number 8 and 10. They added for angle measure, they used radian, and solids angle measure, they used radian. Now, the International System of Units has 9 units. Nowadays, the International System of Units is used in all the scientific fields, all over the world, okay? I hope this video is useful for you. So don't forget to subscribe and like my video if you like it. See you later and goodbye.